lesson is on dividing whole numbers, and we are learning to long divide with whole numbers. This should be a review lesson, but you may have learned a different way of doing long division. If that's the case, please try your best to follow along with this long division standard algorithm. The reason is because when we work with decimals, it's going to be much more important for you to use the standard algorithm so that it doesn't take a very long time to solve the problem. Make sure you ask your teacher if you have questions. All right, so some vocabulary to start off with. We need to know that a quotient is the answer to a division problem, and that the dividend is the number that's being divided. So that's the first number. And this is not in your notes, but you could add it if you'd like. The divisor is the number used to divide the other number. So that would be the second number. In division, it's very important to keep track of which number goes where. If you put the numbers in the wrong spot, you will get the wrong answer. So on your notes page, lesson 3.3, dividing whole numbers, we are trying to finish the essential question or solve the essential question of how can I divide whole numbers? And it first says, Mr. Bradford's class brainstormed different symbols and phrases that indicate division. Circle the correct cards below. Sometimes you will see it in words, in a word problem. Sometimes you will see it as a fraction. Sometimes you'll see it as a division problem or a long division problem. All of these mean division. So pause the video, circle as many as you can, as many as you think are correct, and then unpause the video and check. All right, so splitting something is dividing. We've got this division symbol, the way you probably learned it in elementary school. Then we've got a fraction bar, which is also a division problem. Over here, we've got quotient, which we just learned is the answer to a division problem. If you break something into groups, that is also division. If you have a fraction, again, even if it has a decimal, that is also considered division. And lastly, the long division symbol. So these are all the different ways that we might see division. Now, when we look at the problems, we've got our long division, we've got a fraction, and we've got the division symbol the way we saw it in elementary school. We need to know what each number is called. And remember, we have the quotient, the dividend, and the divisor. And we'll learn in class maybe some way to keep it straight could be using actions. But to start with, let's look. We have 17 on this first one, and that is called the quotient, the answer. This is the form that we're going to be using most today. The first number is called the dividend, and the second number, the number you're dividing, is the divisor, or dividing by, I should have said. In this problem, the top number is the dividend, the first number. The second number is the divisor. And lastly, again, the first number is the dividend, and the second number is the divisor. Just notice where those numbers go. The first number is under the long division symbol, and usually you see it like a little curve, and then the second number goes out in front. Your answer has to be in the set place, and notice we have to keep everything lined up. So you'll see in your learning guide that there are lots of grid lines. You may also want to use grid paper when you're doing your homework problems. Okay, so hopefully you remember that long division is long, and it does take stamina. You can do this. You do need to practice though. Practice will give you speed and the ability to do these without feeling stressed. So the first step is that you have to divide. Then you multiply, then you subtract, and then you bring down. And those 4 steps you keep repeating. You may have learned something to remember them by, but you need to memorize that in order. So for example, if I have this 380, this is not in your learning guide, but just check this out, and we're dividing by 3. We start one place value at a time. And you may want to cover up the other numbers, at least temporarily, so that we can see what we need. So we're not thinking of any of this at first. We're looking at just this 3 divided by 3. We divide first, and we see that we get 1. Then we multiply. 1 times 3 is 3. Then we subtract, and then we bring down the next number. So now we get to uncover the next place value. It is very important that you keep everything in line. So we bring down this 8, then we do it all over again. We divide. 8 divided by 3 is 2. Then we multiply. 2 times 3 is 6. Then we subtract. 8 minus 6 is 2. And then we bring down a 0. We ask ourselves, how many times does 3 go into 20? And so on. So I realize that this was probably difficult to see with all my scribbles, but make sure that you have a way for you to remember division. Okay, when we look at these 3 problems, oops, just gonna clear this. We have 3 different ways, again, of writing a division problem. They all mean the same thing. You're doing the long division. So notice we have grids helping you here. If we actually start with number 3, just because it's a shorter problem, it's got just dividing by 8. We look, under the long division symbol, I would write the dividend, 5,224. You can go ahead and leave that comma off if you want. And then we're going to divide by the divisor, which is 8. That goes out in front. Remember what I said about thinking of 1 digit at a time or 1 place value at a time? You also may want to use your multiplication chart, or you could write down the multiples. That's why we've been practicing. If you want to write down the multiples first, hopefully eventually you'll get these in your head so you don't have to think about it later, but this could help you. Okay, if I think one number at a time, I've got my 5, the 5,000. I want to ask, does 8 go into 5? And I just think of the 5 itself. And no, 5 is smaller than 8. Then I look over to the next place value. I've got now 52, and I get to do both the 5 and the 2. Does 8 go into 52? And absolutely. I want to look for the smallest number without going over. So I see this 48. I think, okay, that's going to be 6 8s to make 48. Then, if I remember my dad, mom, sister, brother, or does McDonald's sell burgers, or just remember divide, multiply, subtract, bring down. I've divided, now I'm multiplying. I do 6 times 8 to get 48. Then I subtract 52 minus 48. I have to borrow, and then I can subtract. And then I ask myself, is 4 bigger than 8? Because if it is, I have to erase and go back. Make sure you're using a pencil. But since it isn't, now I can bring down. I only bring down 1 digit at a time. And I ask myself, does 8 go into 42? And yes, it does. And this time, I'm going to look at 40, which is 5 8s. Then, once I've divided, I multiply. 5 times 8 is 40. I make sure to line up all of these numbers. And then I subtract. 42 minus 40 is 2. And then I bring that 4 all the way down. Make sure that you check to see that 2 is not bigger than 8 first before you bring down. Because if it is, then you got to go back and erase and try that again. But it isn't, so then I do 24 divided by 8, and I get 3. Then I multiply. 3 times 8 is 24. I subtract, and yay, I got a 0 remainder, which means my answer is 653. I apologize, I forgot to mention that we do want to be estimating still. If we estimate, it can help us to make sure our answer makes sense. So if you think of this number, 5,000, remember we underline and circle, that would round to about 5,000. To make it easier to do in our heads, we round. This 8 could be a 10. Or I can leave it 8, but 5,000 divided by 8, I can't do in my head. So 5,000 divided by 10 is 500. I think, is that close to what I got, 653? Yes, good job. All right, so it is a lot of steps, but you can get good at this. You just have to practice. And you may use your calculator just to check, but please try not to use it to cheat. All right, let's go back and do number 2. So we have 3,672. We write it under the long division sign. Then we write 18, the divisor, on the outside. I think to myself, ooh, 18. So that's a bigger number. If you want, you can use your multiplication chart, or you can just write down really small right here the multiples. So I'm going to start with 18, 36, and I'm basically just adding repeatedly. Remember that multiplication is repeated addition. And I don't have to have every single one of these, but I might want to at least get up to 126. Let's start with that. And if we need more, we can get more. Okay, you could also round 18 to 20. And remember, we're going to round to get our estimate in our head anyways. So this is about 4,000 divided by 20. That tells me that my answer is going to be close to 200. I knew that because I can divide by 10 on the top and the bottom, and then 400 divided by 2 is 200. I also can think, when I look at this number, I can think of this like a 2. And I can think of this number like just the 3. And I can ask how many 2's go into 3. If you want to round like that, you can. But then know that that's just an estimate and you might have to fix it. So if I think it only goes in one time, that's actually not going to work. But I definitely know that 18 does not go into 3. It does go into 36. So that idea of changing it to 2 and 3, that's just to round in your head. So I know it's at least once, but do you see right here that I've got 2 of them is exactly 36? So that means I'm going to divide 36 by 18 is 2. And then I multiply. 2 times 18 is 36. Then I subtract. I get 0. And then I bring down the 7. I start over. 7 does not work because 18 does not go into 7. So please remember to keep your 0 and keep it lined up. Then I can just skip all the steps because 0 times 18 would be 0. If you want to write it, you can. But I get to go to the bring down stage, 72. 18 goes into 72, ooh, right here, exactly 4 times. And I know that 18 times 4 is 72, so I'm just left with 0. Is 204 close to 200? Absolutely. So I'm going to box my final answer. Again, you don't have to show all of this work. If you have another way that helps you to do these problems, go ahead and use it, but make sure you work towards this standard algorithm because we'll need it when we do decimals. Okay, let's try number 1. So now we've got 27, and again, you can write down the multiples of 27. It just might take you a little bit longer to finish your work. And this one is not in our multiplication table. So you would have to just add in your head. Add 18, or add 27, add 27, add 27. Otherwise, you use my other method and think of like this like 30 or like 3. And then you'd look at just this, 3 into 11, which is close to 10. So I'm thinking that our first digit might be around 3, but it might not. It might be one more. Let's see. So let's rewrite this down here into the grid. Again, you could just use regular paper if you'd like, but it's important to keep your place value. 27 does not go into 1. Some people put zeros there. You could also just leave it blank. 27 does not go into 11, but it does go into 113. And if I look over here, I see 108 is the closest without going over. I have 1, 2, 3, 4 27s. So that's close to what we thought it might be. We thought it might be 3. Now we go ahead and multiply. Dad, mom, sister, brother. I divide, then I multiply. 4 times 7 is 28. Then I carry the 2. 4 times 2 is 8 plus 2 is 10. Now, you may be wondering, why didn't you just use your table? And I was just showing you, if you didn't have the table, what you would have to do in your head. 3 does not subtract 8 very well, so I have to borrow. I take a 10 and I make it 13. Now I have 13 minus 8 is 5, and 0 minus 0 is 0. All of these are 0. 5 is a good number because it's not bigger than 27. Now I bring down 54. Ooh, I see that that's 2 27s. I go ahead and subtract, and I have no remainder. Ooh, now I realize that we forgot to estimate again. So if we think of this like 1,000 divided by about 30, do you see that that would be about 30 as an answer? Obviously not quite, but 42 sounds like a good answer. Check. All right, turn the page and you'll see when we have real life problems, when we are thinking of addition, like we started off the unit, we increase something, at least when we're talking positives. When we're talking subtraction, we decrease, at least again when we're talking positives. To combine might be making things brought together. When we have multiplication, that's repeated addition, but we're talking division today. And that is repeated subtraction, and that's why we end up subtracting over and over. Make sure that you know how to mark the text in math class. It's called marking for math. We circle key numbers, we underline the question, we box the operation, and identify the label. And this one I need you to put stars next to, because the label is required for any word problem. Don't worry about this table yet. We'll talk about that more when we have different word problems. But here's an example of what you could do before you mark the text. We could sketch a diagram. Some people call these tape diagrams. You could also just call it a graph or a grid. And someone also pointed out that this looks a little bit like a ratio table, but this is the whole, the $65.48 we're going to talk about. And we're seeing if 4 friends, circle those numbers, 4 friends went out for dinner and their total bill was that $65.48. If the friends split the bill evenly, how much did they each pay? Notice you underline the question, you box what's happening, it's splitting, which we know is division, and you have to pay attention to the label. The label will be dollars. Okay, notice we have this $65.48 broken into 4 equal parts. That's basically what's happening. And we will learn to do this later with decimals, but you just need to get the idea of how to mark the text. And don't forget to label your answers. Okay, so the problem we're going to do today, though, with whole numbers, in preparation for open house, the campus secretary copied handouts in sets of 25. Excuse me. If she made 1,675 copies, then how many sets did she copy? If you are looking at this problem, how many sets you could consider as dividing? You're dividing it into equal pieces. I have 1,675 copies, and that is what I'm dividing, excuse me, into 25s. Remember what we learned? Divide. Okay, we can't divide 25 into 1 or 16. Sorry, I got something stuck in my throat. But we can do 167 divided by 25. And that would be 6, which would be 150 when you multiply. When you subtract, you get 17, which is good because it's less than 25. And then we bring down. We do 175 divided by 25, which is nice and even. We get 7. When we multiply and subtract, we see that we have exactly 67, but we need a label. We forgot to squiggle a label. How many sets? The label is usually in the question. If you do not label, then you will not get your answers correct. So be sure to label every word problem. Okay, and one final problem. Mr. Jackson hires his neighbor Timothy to walk and feed his dog for the month of June. He tells Timothy that he will pay him $270. How much will Timothy make each day? Now, this one has a hidden number, the number of days in June, and hopefully you know that that's 30. So I'm gonna write 30 in a circle. We're trying to figure out how much he makes each day. So if you think of that, that's gonna be taking $270. We divide the money into the days, 30. And when you do that, 30 does not go into 2, it does not go into 27, but it does go into 279 times. And this is the perfect example of what I was talking about before, where you take 3 and figure out how many times it goes into 27. It works perfectly. So I end up subtracting and get no remainder, which means I think it should be 9, but I need a label. You have to label. So I see, oh, dollars, that's how much he makes each day. In your homework, you just have to label it as $9. And notice we answered the question, and does it make sense that he would get $9 a day? Yeah. So check. If you got $9,000 a day, that would not make sense. Okay, for your summary, you want to answer the essential question, how do I long divide? To long divide multi-digit numbers, it's good to start with an estimate and then complete division using the long division strategy. All right, currently you are doing pages 19 and 20, although those may have changed. You are submitting the spreadsheet with all green answers, and don't forget to label all word problems. If you don't label, it'll mark it wrong. Also, when you write your code for your answer, you need to do it with capital letters and all together, no spaces. Hint, a dozen in this case, even though it's baking, is going to be 12. All right, if you have any questions, please talk to your teacher. Have a great day.